Hello everyone. In the last class we discussed about workability, factors affecting workability. Today we are looking forward. So how to measure workability? So measurement of workability is so important because workability will place a much more vital role in the strength gaining factors. So it is important to measure workability in the beginning. Measurement of workability will be done with the generally 4 tests. The first one is slump cone test. Second one is floatable test. Third one is VB consistometer test, and the fourth one is compaction factor test. Let us see one by one. Slump cone test. As it is saying, we are going to form a slump and the height of the slump is taken into the account. So what is a slump then? Slump is nothing but a set forth mass of concrete without any support, or a slidden mass of concrete without any support. In the general English, slump means sit aforth, we will say. Okay, from that it is being extracted. So in the slump cone test, it is going to measure the consistency of the concrete which is to be used in the different projects. Say if we are using the concrete for footing purpose or beam and column construction purpose or slab purpose. For different kind of concrete placement, the different water consistency is required. So concrete should not be too harsh, concrete should not be too rich, and concrete should not be too lean. It should be with the optimum conditions. So it has to satisfy the requirements of the placing and finishing. So it has to completely satisfy with the workability. As the water content increases in the concrete, which will increases the slump value. Slump value is the value or a measurement which is taken from the top of the slump cone till the set forth mass of concrete. So that height is called as slump value. It will be measured in terms of mm. Say for example, if the concrete is to be used for the slab purpose, the slump value will be 85 to 100. In some of the cases we will go for 100 to 110 also. So that is nothing but which is in mm. So that slump value will represents the more water cement ratio or the flowability of the concrete, or it represents the consistency of the concrete. So in the measurement of slump with the use of slump cone test, we are going to take the concrete with the proportion of 1:2:4. That is, if I am taking 2.5 kg of cement, then I will take 5 kg of fine aggregate and 10 kg of coarse aggregate. Measurement of the slump will be done according to the IS 1199-1915 codal provisions. So according to that test, we are going to use the concrete proportion 1:2:4. So if I am taking 2.5 kg of cement, then I will take 5 kg of fine aggregate, then 10 kg of coarse aggregate, and then I will mix with the different water cement ratio, because when we added with the concrete proportion with water cement ratio 0.5, it will give some value of slump. If I am increase the water content for 0.6, that is water cement ratio is 0.6 is taken, then it will give us some other slump value. So it is being measured with the different water cement ratio. So you will come to know how to do the test. Here you are learning how to do the slump cone test.
Slump test is the most commonly used method of measuring the consistency of concrete work where the nominal maximum size of the aggregate does not exceed 38 mm. This method can be employed either in the laboratory or at the site. Apparatus required for slump test. The mold for the test specimen is in the form of the frustum of a cone having the bottom diameter of 20 cm, top diameter 10 cm, and height of the cone is 30 cm. A metal plate of thickness 1.6 mm is used as a base. A tamping rod of 16 mm diameter and 0.6 meters long is used. Let us now see the step-by-step procedure for concrete slump test. The internal surface of the mold should be thoroughly cleaned and freed from moisture and any set concrete before commencing the test. The mold is placed on the smooth metal plate. The mold is filled in 4 layers, each approximately 1/4 of the height of the mold. Each layer should be tampered with 25 strokes with tamping rod, such that the strokes are distributed over the cross-section. After the top layer is filled, the concrete is struck off level. The mold should be removed from the concrete by slowly raising in the vertical direction. Now, you will notice concrete tends to subside. This subsidence is referred as slump of concrete. This slump value is then measured by the difference of the height of the mold and that of the highest point of the specimen. This difference in height is taken as slump of concrete. The pattern of a slump is displayed on the screen. The slump value and its acceptable usage are tabulated on the screen.
Finally, if you are at the site as a site engineer and you are doing the slump cone test and you are getting the slump as either collapse slump or shear slump, those values to be abandoned. You don't have to take those values. You have to take the values only for the true slumps, that is to be referred as the slump of that concrete, and based on that you have to go for the carrying of work. Second test is floatable test. This test will measures concrete workability as well as cohesiveness as well as capability to be segregate and then its adhesiveness with respect to the matrix of the concrete. That is being measured in this test. Here what we are going to do is just we are going to place the mass of concrete and then it is being given with some jolting action. That standard jolting will causes the flowability of the concrete. If the concrete is become segregated, then it is rejected. If it is become it is not an adhesive to the aggregates or the mass or matrix in the concrete, then it is abandoned. So such test is done with this method. We are going to do measure of the spreading nature of the concrete. So here we are taking the concern of spreading. So standard diameter of the spreading is being measured with respect to the mass of concrete spreaded after giving the jolting action.
Floatable test is generally done in the laboratory to determine the fluidity of concrete. The apparatus consists of mold should be made of a smooth metal casting, in the form of the frustum of a cone with internal dimensions of 25 cm base diameter, 17 cm upper surface diameter, and height 12 cm. And the floatable about 76 cm in diameter over which concentric circles are marked. Let's now see step-by-step procedure to do this test. The tabletop is cleaned of all gritty material and is wetted. The mold is placed in the center of the table, firmly held and is filled in 2 layers. Each layer is rodded 25 times with a tamping rod. After fully filled, the excess concrete is leveled off. Now, lift the mold vertically upward. You will notice concrete stands in the shape of the mold. The table is then raised and dropped 12.5 millimeters 15 times in about 15 seconds. The diameter of the concrete spread is measured in about 6 directions to the nearest 5 millimeters and the average spread is noted. The flow of concrete is the percentage increase in the average diameter of the spread of concrete over the base diameter of the mold. Flow in percent is calculated by dividing spread diameter in centimeters minus 25 divided by 25 into 100. Thus, the value of flow percent is calculated from 0 to 150%. A close look at the pattern of spread of concrete can also give a good indication of the characteristics of concrete, such as the tendency for segregation.
Floatable test values are measured in terms of percentages. If the percentage of the floatable test is high, it is about in the range of 100 to 150, which is having a more water cement ratio, or it's having the more flowing capacity. If we are using admixture, then also we will get this much value. If it is indicating less, that is nearer to the 0, then it is having the harsh, or it's having the lesser water content. So it is used based on the requirement. If I am doing the concrete for the pavements, then I need the concrete with very less water content. Then I will go for the lesser floatable results, about lesser percentages. And if I am doing the concreting for the compacting concrete purposes, then we are going for the higher percentage of the floatable test values. Third test is compaction factor test. In this test, there will be the two hoppers, and which all are separated by the vertical distance of 20.3 centimeters each, and then below that there will be a cylinder. Okay, in the top hopper we will place the concrete, and then we will open the tap rod, and then it will be passing into the next hopper, then it is going to pass into the cylinder. So from this we are going to measure the partial compaction done by the concrete itself is being compared with the manual compaction or the standard compaction done by the manual method. That is, in the 4 layers we are going to place the concrete in the cylinder, and then it is weighed, and then it is measured. So such compaction is compared in this test. So it is called as compaction factor test. If the compaction factor is high, that will indicate more workable concrete. If the compaction factor is less, then it is indicating less workable concrete. Compaction factor test will be done according to the IS 1199-1959 codal provisions. We are going to take the concrete with the proportion 1:2:4. Here we are taking 2.25 kg of cement, then 4.5 kg of sand, then 9 kg of aggregate. With this we are going to select different water cement ratios for testing. From that we will get the different compaction factor. If the compaction factor is high, that will indicate more workable concrete. If the compaction factor is less, then it is indicating low workable concrete. Generally, compaction factor test either can be done at the site, or it can be done in the laboratory also. You can do the compaction factor test in the site by taking the complete setup into the site itself, and it is particularly used for the low workable concretes.
The compaction factor test is designed generally for use in the laboratory, sometimes used in sites. This test has an advantage of using this method for concrete mixes of very low workability. The compaction factor apparatus consists of the upper hopper of dimensions, top internal diameter 25.4 cm, bottom internal diameter 12.7 cm and internal height 27.9 cm. A fixed lower hopper of dimensions, top internal diameter 22.9 cm, bottom internal diameter 12.7 cm and internal height 22.9 cm. And a cylinder C of internal diameter 15.2 cm and internal height 30.5 cm. The distance between upper and lower hoppers and lower hopper and cylinder is 20.3 cm. Procedure. The sample of concrete to be tested is placed in the upper hopper up to the brim. The trap door is opened so that the concrete falls into the lower hopper. Then, the trapdoor of the lower hopper is opened and the concrete is allowed to fall into the cylinder. The excess concrete in the cylinder is leveled. The outside of the cylinder is wiped clean. Now, the cylinder filled with concrete is weighted. This weight is known as the weight of partially compacted concrete. Then, empty and clean the entire cylinder. Now, fill the cylinder with concrete in layers where each approximately is 5 cm deep. Once fully filled, the top surface is leveled off. The outside of cylinder is wiped. Now, weight the cylinder. This weight is known as the weight of fully compacted concrete. The compaction factor is equal to the ratio of the weight of partially compacted concrete with the weight of fully compacted concrete. With the help of compaction factor value, the degree of workability is calculated with the help of the table.
Remember, the compaction factor value will be the just number. It won't be having any units. It will not be in percentage. It will not be in any mm or meter scale. It will be a just number. Less than 1 it should be. If you are getting more than 1, then you have to recheck your process. Last one is VB consistometer test or VB consistency test, we will say. Here we are going to measure two things. One is slump and other is its filling ability. In this test, we are going to place the slump cone and then we are going to fill it, and then we are going to remove it by taking the measurement of the slump, and then after removing we are giving some vibration action. From that it is going to fill the mold. That is how much it is having the capacity to remold. That is also being measured. In this case, we are taking two things in the consideration. One is its consistency maintenance and other is its capability to be bleeded, or bleeding of the concrete is being tested here. This test also measures the mobility of the concrete and it is indicating the time. So how much time it has taken for remolding is into the consideration. If higher the VB seconds, that it will indicate the low workable concrete. If less will be the VB seconds, that it will be having a high workability.
And the mobility and compactability of concrete. The VB consistometer test consists of a vibrator table resting upon elastic supports, a metal pot, a sheet metal cone open at both ends and a graduated rod connected with glass disc. The entire setup is shown on the screen. For dimensions of the various shapes are designed based on the IS 11991959. Today, we are not going to concentrate on dimension. Let us now start with the procedure. Place the slump cone inside the cylinder. Now, fill the concrete in 4 layers. Each concrete is 1/4 of cone height and tamper the surface 25 times. Once filled, struck off the excess concrete. Move the glass disc attached to the swivel arm and place it on the slump cone such that it touches the top of the concrete level. Note down the reading in the graduated rod. Next, remove the cylindrical cone by raising the cone slowly in the vertical direction. Again, place the glass disc and determine the reading. Now, switch on the electrical vibrator and at the same time switch on the stopwatch. The concrete will start to spread in the cylinder container. Continue the vibration until the concrete is remolded and the surface of the concrete becomes horizontal. Stop the vibration and stopwatch. The time in the stopwatch denotes the workability of concrete. The time is expressed in VB seconds. Calculations in VB consistometer. Initial reading in the graduated scale before remolding m. Final reading in the graduated scale after remolding bm. Slump value is equal to a minus pm. And the consistency of the concrete is measured in VB seconds. The workability conditions with respect to VB time are displayed on the screen.
So from all these 4 tests, what we have seen, slump cone test, it is best for the aggregates having the size less than 40 mm. For those concretes we can use it, and generally slump cone test is used in all the type of concretes, but it is more preferable in the general usages rather than the special cases, such as if you are using it for the self-compacting concrete, it is not suitable. There we are going for the different tests. And second one is floatable test, which is suitable for the rich concrete and which is having the more workability, as well as for the concrete which are to be filled in the high reinforced areas. So on those cases we will go for the referring of floatable test. But the floatable test is a laboratory test. You have to do it in the laboratory. It is not possible to take it for the site. And then third one is compaction factor test. There you can use it for the low workable concrete as well as the concrete with lesser water content, and you can use it either in the site as well as in the laboratory. That is an advantage, and there is no restriction for the size of the aggregates. And next one is VB consistometer test or VB consistency test, that you can use it for the rich concrete as well as low workable concrete and dry lean concrete. For those concretes you can use it, and there is no restriction for the size of the aggregates. You can use it for the any size of aggregates, and it is generally used for the high strength concretes as well as more flowing concretes, such as which are having the capability to the filling of heavy reinforced areas. For those cases we will go for the use of VB consistency test. But in the site we used to do the test like we didn't have the slump cone or some other test methods. So generally by the practice we used to check the consistency of the concrete just by taking the mass of the concrete, and then we used to make it as a mud ball, a concrete ball, and that concrete ball is made to flow or throw above in the free air or free atmosphere for a height of 1 meter, and then it is to be catched. So after the catching, the concrete is remaining its ball shape, then it is having good consistency. If it had lost its shape, then it is having either hash mix or it is maybe having more water content, that is assumed. So we are going to either reduce the water content or we are going to increase the water content. Based on that experience we used to do.